Asteroid mining stands out as one of the most exciting and promising fields in space exploration. This innovative endeavor has the potential to reduce our planet's reliance on limited natural resources by utilizing extraterrestrial materials, and it offers the opportunity to open new doors in space exploration. The valuable metals and minerals contained in asteroids could make significant contributions to economic and industrial activities on Earth. However, to realize this potential, various technological, legal, and ethical challenges must be overcome. In this video, we will delve into the evolution of asteroid mining from the past to the present, examine current projects, and explore visions for the future. The idea of asteroid mining has traveled a long path from science fiction to scientific research. First proposed in the late 19th century with dreams of space exploration and utilization, this idea was prominently featured in the works of authors like Jules Verne. However, its conceptual foundations and scientific consideration had to wait until the mid-20th century. The 1950s and 1960s saw intense interest in space exploration and colonization alongside the space race. During this period, the potential resources of asteroids and other celestial bodies began to be explored. As NASA and the Soviet Union collected data on the Moon and other planets, scientists developed theories about the internal structures and compositions of asteroids. The 1970s and 1980s marked a time when the concept of asteroid mining was taken more seriously. During these years, the surface compositions of asteroids began to be analyzed, and potential mining methods were discussed. In the 1980s, NASA conducted the NEAR project to study asteroids and identify those suitable for mining. The early 21st century saw more concrete steps being taken toward asteroid mining. Significant advancements were made in this field through private companies, government-supported projects, and international collaborations. In the 2010s, pioneering companies like Planetary Resources and Deep Space Industries attracted attention with serious investments in asteroid mining projects. These companies emphasized that extracting valuable metals and resources like water from asteroids offers great opportunities for both the Earth's economy and space exploration. Today, asteroid mining is no longer just a science fiction concept but is seen as an achievable goal. With technological advancements, legal regulations, and international collaborations, efforts in this field have accelerated. This exciting and rapidly developing area will play a critical role in ensuring humanity's sustainable presence in space in the future. Asteroids are small, rocky celestial bodies generally found in the asteroid belt between Mars and Jupiter, with some also located in near-Earth orbits. They can vary in shape, size, and composition. Understanding the classification and composition of these celestial bodies is critical for the successful implementation of asteroid mining. Asteroids are generally classified into three main types. Carbonaceous asteroids are the most common type, comprising about 75% of all asteroids. They are dark in color due to their high carbon content. Their composition includes carbon, water-rich minerals, and clay. Rich in water and organic compounds, they are significant for water production in space and supporting space colonies. Additionally, these asteroids could serve as a fuel source for future space travels. These asteroids provide information about the chemical composition of the early solar system. Silicaceous asteroids make up about 17% of all asteroids. They are known for their bright and rocky nature. Their composition includes silicates such as olivine and pyroxene, as well as nickel-iron alloys. Due to their metal content, they are valuable for construction materials and technological applications. These asteroids may be differentiated into distinct layers of metal cores and silicate mantles through differentiation processes. Metallic asteroids are rarer, accounting for about 8% of the total asteroid population. They have a bright and metallic surface. Their composition includes some valuable metals like nickel, iron, and platinum. Due to their high-value metal content, they are the most sought-after asteroids. They have significant industrial and economic potential. Their surfaces are generally smooth and shiny. The most suitable types of asteroids for mining depend on the valuable resources they contain and the feasibility of extracting these resources. The surface properties of asteroids are crucial in determining mining methods. For instance, the presence of water ice in carbonaceous asteroids allows mining by heating to produce water vapor. For silicaceous and metallic asteroids, mechanical excavation and smelting techniques might be more appropriate. Space mining, aimed at extracting valuable minerals from asteroids, is an innovative and forward-looking field. This process entails significant technological and engineering challenges, and various techniques are being developed to overcome these difficulties. Key techniques include excavation, drilling, and smelting. The excavation technique involves mechanically removing minerals from the asteroid surface. This method is performed using various tools and machines depending on the asteroid's surface structure and composition. The excavation process typically uses mechanical arms, scoops, and excavators to dig through the loose soil and rocks on the asteroid's surface to extract minerals. This method is particularly effective for asteroids with loose surfaces and rocky structures. For example, Planetary Resources' Arcade series of vehicles use these mechanical excavation techniques to collect surface samples. The laser cutting method uses high-energy laser beams to vaporize or cut through the asteroid surface. This technique is highly effective for asteroids with hard rock structures and for precision work. Lasers offer precision and control while minimizing the release of pollutants. This method allows for the careful extraction of valuable minerals on the asteroid's surface. Drilling is used to access the internal structure of asteroids and extract deeper mineral deposits. It plays a crucial role in reaching subsurface mineral beds. Mechanical drilling employs drilling machines, drills, and bits to create holes in the asteroid surface and access the underlying minerals. This method is ideal for accessing subsurface mineral deposits. For example, Japan's Hayabusa 2 mission used a drilling device to collect samples from the Ryugu asteroid, drilling into the surface to retrieve valuable specimens from within. The thermal drilling method involves using high-temperature devices to melt or vaporize the asteroid surface. This technique is used on asteroids with hard and dense structures. High temperatures allow for the melting or vaporization of rocks, enabling access to deeper layers. Thermal drilling is particularly effective for extracting hard minerals. Melting is a technique that allows for the in-situ processing of materials rather than direct extraction. This method heats the materials on the asteroid surface, causing the minerals to separate and be collected. The in-situ resource utilization (ISRU) technique involves extracting water and other volatile substances from asteroids and making them usable in space. This technology melts or vaporizes materials on the asteroid surface to collect water ice, metal, and other valuable resources. ISRU technology is crucial for long-term space missions. For instance, NASA's ISRU projects are used to process water ice on the surfaces of the Moon and Mars, and these technologies can also be applied to asteroids. The mining techniques developed in the field of space mining enable the efficient extraction of valuable resources from asteroids. Excavation, drilling, and melting methods are selected and applied based on the types and structural properties of different asteroids. Asteroid mining is one of the most innovative and forward-looking fields of space exploration. However, since this process requires working in the challenging conditions of space, it demands numerous technological innovations and engineering solutions. Let's take a closer look at what these technologies are and how they work. First, asteroids need to be discovered and captured. This process begins with space telescopes and sensors. Projects like NASA's NEOWISE mission use infrared telescopes to discover and classify asteroids. These telescopes are vital for determining the orbits and compositions of asteroids. Additionally, remote sensing techniques such as spectral analysis and radar imaging can be used to gather detailed information about the surface properties of asteroids. Various mechanical systems have been developed to capture asteroids. Robotic spacecraft, as seen in NASA's Asteroid Redirect mission, use special gripping arms to capture asteroids and move them into a safe orbit. These systems form the first step in asteroid mining. Once an asteroid is captured, the mining process begins. At this stage, robotic mining vehicles come into play. Companies like Planetary Resources have developed autonomous robots to collect mineral samples from the surfaces of asteroids. These robots move across the asteroid surface, performing mining operations. Excavation and drilling systems also play a crucial role. Methods such as mechanical excavation, laser cutting, and drilling are used to extract minerals from the asteroid surface. In-situ resource utilization technologies have been developed to process the resources extracted from asteroids on-site. These technologies extract and process water and other volatile substances from asteroids, making them usable in space. Logistic and transportation technologies are required to transport the mined resources from asteroids to Earth or another destination. Recycling and storage modules allow for the temporary storage and processing of the minerals obtained from asteroids. For instance, the inflatable modules developed by Bigelow Aerospace can be used as storage and living spaces in space. Orbital propulsion systems play a critical role in transporting minerals obtained from asteroids. Various propulsion systems, such as chemical propulsion, ion propulsion, and solar sails, are used in this process. The Dawn spacecraft, using an ion propulsion system, demonstrated the effectiveness of this technology by studying the asteroids Vesta and Ceres. Energy production and storage in space are also important topics. Solar panels and nuclear power sources provide energy to mining equipment. NASA's space vehicles, like the Mars rovers, can conduct long-term missions using solar energy and radioisotope thermoelectric generators. In the processes of asteroid mining, data collection and management are also of vital importance. Artificial intelligence and autonomous systems optimize mining processes and perform autonomous operations. For example, NASA's Mars Curiosity rover has autonomous navigation and analysis capabilities. Communication and control systems also play a significant role. High-speed data transmission systems ensure continuous communication between Earth and spacecraft. Global communication networks like NASA's Deep Space Network enable constant communication with spacecraft, ensuring the effective use of these technologies. These advanced technologies help us make great strides in the field of asteroid mining. Thanks to these innovations, the processes of extracting valuable resources from asteroids and transporting these resources to Earth or other points in space are becoming more efficient and secure. Asteroid mining has the potential to revolutionize future space exploration and economic development. Significant progress has been made in asteroid mining through both government-supported projects and private company initiatives. NASA's OSIRIS-RX mission, launched in 2016, aimed to collect samples from the asteroid Bennu and return them to Earth. This mission successfully collected samples from Bennu's surface, and these samples were returned to Earth in September 2023. These samples provided valuable information about the composition of asteroids and offered important data for future mining operations. Japan's Hayabusa mission collected samples from the asteroid Itokawa and returned them to Earth in 2010. Following this success, the Hayabusa 2 mission collected larger and more diverse samples from the asteroid Ryugu, and these samples returned to Earth in December 2020. These missions provided important experiences and data for asteroid mining technologies. ESA's Hera mission aims to study the binary asteroid system Didymos, specifically investigating the smaller asteroid Didymoon. This mission, working alongside NASA's DART mission, will be the first collision test aiming to alter an asteroid's orbit. The Hera mission will help us understand the structural properties and surface dynamics of asteroids. Planetary Resources is a company that develops commercial technologies for asteroid mining. The Arcad series space telescopes are designed to explore potential mining targets. The company aims to extract water and valuable metals from asteroids. However, financial difficulties have slowed down the projects. Transastra is another private company developing technologies for asteroid mining and fuel production in space. The Mini Bee and Queen Bee spacecraft aim to extract water ice from asteroids to produce fuel in space. These projects aim to establish a sustainable economy in space. These innovative technologies are paving the way for sustainable economic activities in space and will play a significant role in future space exploration. Don't forget to subscribe for brand new scientific content.